When it comes to solving systems of equations, okay, what I want you guys to understand is I don't typically care what method you use on a quiz or a test. I ultimately just want you guys to solve the system of equations. On your homework, I do want to be very specific. So last section that we did was all supposed to be with substitution. That means every single problem I want you guys to do with substitution, okay? When we do elimination here, I want you guys to use elimination, okay? So the elimination method is a method for solving systems of equations by adding or subtracting to eliminate a variable. So step 1 is to make sure that the equations are lined up. Step 2 is to add or subtract. To eliminate a variable with common coefficients. Step 3 is to solve for the remaining variable, and step 4 is to substitute your answer for either the original equation and solve for the other variable. Oh, into either equation, I'm sorry. So I can substitute the value, like if I eliminated and got a value for x, then I could use either equation to figure out what y is. So I'm going to do a few of these, and then I'll cut you guys loose to just work on finishing up yesterday's assignment, getting everything submitted into Gradescope. Okay. All right, so if I look at this first one here, both of them are equal to y. So I can set the equations equal to each other, and I can solve for x. So subtract x. I get 2x plus 4 is equal to negative 2. Subtract 4 from both sides. So I get 2x is equal to negative 6. Divide both sides by 2, and I get x is equal to negative 3. I don't care what equation you pick. You can pick the top one or the bottom one. I like the bottom one because it looks a lot easier. And I take my negative 3 that I got and I plug it in for my x into my bottom equation here. And then I solve, so I get y is equal to negative 5. So my answer is negative 3, negative 5. Okay. Questions that you guys have so far? Let's see. Which one do I want to do next? So if I look at any one of these, I can look at example 4, for example. And when I go to look vertically, right? So I'm looking vertically to see how I can eliminate one of the variables. what I notice is that I could eliminate y if I use subtraction. So if I multiply everybody by a -1, I still have my first equation, but I have a positive 2x, a minus 2y, and a minus 18. Now I can add straight up and down. So I get 6x is equal to -12. Divide both sides by 6, and x is -2. I could have done subtraction and not rewritten it out. But what I did is I took a negative and I multiplied it by every single term instead. And I'm looking vertically to add. Questions?
Could you do another one that's similar to that one?
Yeah, I'll do it in a second. So if I have, so I can pick one of my equations to solve for y. I'll solve for y first. So I have 4 times -2 plus 2y is equal to 6. So -8 plus 2y is equal to 6. Add 8 to both sides, so I get 2y is equal to 14. Divide by 2, and y is 7. So I get -2, 7. I'll go up and do 3. Again, if I want to use subtraction, I'm going to take my negative and I'm going to distribute it all the way through. And the reason why I did that is because when I look vertically, nothing can really happen with my y's because they have different numbers in front. But when I look at x, they're the same number in front, right? So they have the same coefficient. So I can take my 3x minus 10y is equal to 14. All I did is I just copied down my top equation. I distributed negative to my second equation. So I took my negative to my 3x, took my negative to my 9y, that turned it into a plus 9y. Took it to the positive 15, so that's why I have a -15. Now I add vertically. So I get no more x's, they're all gone. I get a -y is equal to a -1, so y is 1. I then pick whatever favorite equation I want, either the top one or the bottom one. I lost the original question. Is it minus? Yeah, it's minus. And I plug in +1 in for y. So I get 3x minus 10 is equal to 14. Add 10 to both sides, so I get 3x is 24. Divide by 3, so I get 8. So my coordinate point is 8, 1. Yes, Trejo.
What if we substituted y?
Huh? Okay. I could do another subtraction one. When I look vertically, nothing happens good with my y's. They both have different numbers in front. But when I look at my x's, they have the same number. So I would take one of them and distribute a negative all the way through. So x plus 4y is equal to 13. Then I'd have negative x plus y is equal to a negative 3. So you add vertically. So I get 5y is equal to 10. Divide both sides by 5, so y is equal to 2. And then I can pick any equation I want. I can pick the top one or the bottom one. I always pick the top because it's just there. So I have x plus 4 times 2 is equal to 13. So x plus 8 is equal to 13. Subtract 8 from both sides, so x is equal to 5. So I get 5 comma 2. So I want one of them to be positive and I want one of them to be negative. That's ultimately what I want. Sometimes I'm nice, right? The problems are nice. And when I look vertically, one of them is already positive and one of them is already negative. Then that makes life really easy. Yes.
So this only works when there's two variables that are the same for both equations?
Yes. Now, I will start to change it so that they look that they're both in standard form. But then you, in order to get them the same, you have to now do something to both equations, not just one of them. But that's not until a week from Monday. Okay. Other questions that you guys have? So sometimes we're nice, right? So if I look at like question number 6, right? When I look vertically, it's pretty good now because one of them is positive 3 and one of them is a negative 3. So I can just add what to start off with. So I get 8x is equal to 24. Divide both sides by 8, and I get x is equal to 3. So now that I've looked vertically, and I was automatically able to cancel one of them out, right? Now what I can do is I can then pick one of my equations, either top or the bottom. So I plug in my 3 in for my x. So I get 30 minus 3y is equal to 18. Subtract 30 from both sides. So you get negative 3y is equal to 12. Divide both sides by negative 3. And y is equal to negative 4. Oh, wait, I lied. Positive 4. Because it was a negative 12. Not a positive 12. Your no solution and infinitely many solutions are are pretty easy to look at, right? So if I look here and I look at question 10, right? Huh? So if I multiply one of them by a negative, I had a 3x minus 4y is equal to negative 10. I distribute a negative to all my terms. And I get all of my variables to cancel out, and I get 0 is not equal to 3. So they are parallel, that is correct, which means that there is no solution. Now you will get weird ones. Trejo, you had a question, or are you okay? Huh? Are we done with class? Okay. Real quick, and then I'll let you guys go. Sometimes you need to change things into standard form. Before you start. So if it looks like substitution, change it into standard form first.